Now we have the same difference equation as discussed in the previous example with this input signal and also initial condition. Determine Hn using classical method. So first we replace the input signal Xn with impulse response signal delta n, and also the response of Yn with Hn symbol. From the characteristic equation determined previously, we have different real roots r equal to 1 over 2 and 1 over 3. Therefore, we have our homogeneous solution as this one, where we replace Yn with Hn. For zero state response, we assume that the initial conditions is 0. Therefore, we need to generate the auxiliary condition for n equal to 0 and equal to 1. In this case, we need to determine H0 and H1 using the given difference equation, where we already replace Yn with Hn and Xn with delta n, the impulse signal. So for n equal to 0, okay, we plug in this equation, n equal to 0. We need to assume that the initial condition for zero state response is 0. So H minus 1 is 0 and H minus 2 is 0. So for impulse response, for n equal to 0, the value is 1. So in this case, we obtain H0 is equal to 1. So we repeat for n equal to 1, we plug in n equal to 1 in this equation with the condition of initial condition H minus 1 is equal to 0, H0 is equal to 1 as determined previously, and for impulse signal n equal to 1 is also equal to 1. So we can determine H1 equal to 5 over 6. So by using the previous determined value of H0 and H1 for n equal to 0, we plug in this homogeneous equation n equal to 0 and use the value of H0 equal to 1. We have this first equation, and for the second equation for n equal to 1, we use the value of 5 equal to 5 over 6 for H1. We have this second equation. Therefore, we can determine the unknown gain A equal to 3 and B equal to -2. So we have our homogeneous solution Hn equal to this 3, 1 over 2 with the power of n minus 2, multiply with 1 over 3 with the power of n. 1 over 2 and 1 over 3 are the different roots that we determine from the characteristic equation for homogeneous solution. 3 is the unknown gain, the gain A, and -2 is the gain B minus 2. Multiply with UN.